Good afternoon, everyone. Can you hear me?
Yes.
Good afternoon.
Yes, okay. Thank you very much. Once again, good afternoon, everyone. Introducing myself, I'm Sureka Pereira, Program Quality and Design Analyst for UNDP Sri Lanka. My area of work mainly covers climate change and disaster risk reduction. I have been working with the Disaster Management Center since its inception in 2005. So with that introduction, I warmly welcome everyone who has joined with us for the International Symposium on Multi-Hazard Early Warning and Disaster Risk Reduction. It's my pleasure today to chair this session on disaster preparedness with Dr. Sinma, who has joined all the way from Cambodia. A warm welcome to you, Dr. Sinma, for this symposium. And when it comes to disaster preparedness, it refers to measures taken to prepare for and reduce the effects of disasters. That is to predict and where possible, prevent disasters, mitigate their impacts on vulnerable population, and also to respond to and effectively cope up with their consequences. Therefore, disaster preparedness plays a key role in building the resilience of vulnerable communities. Therefore, it is very important that we pay enough attention to research in disaster preparedness. With that backdrop, we have 6 presentations lined up for the technical session today. Without further ado, I will hand over the floor to Dr. Zinma to introduce herself, introduce the ground rules, and facilitate the presentations. Over to you, Dr. Zinma.
Thank you, Surika. Good afternoon, ladies and gentlemen. Welcome to the technical session. I am Zima Lin. I am head of remote sensing department at Mandalay Technological University, Mandalay. I am from Myanmar. Actually, my background is electronic engineering, and I joined the remote sensing department after getting the postgraduate diploma in remote sensing and GIS from Indian Institute of Remote Sensing, Dehradun, India. As our department, we have the responsibility to teach the remote sensing and GIS subject to the students at MTU, and also to do the research related to its application. Our interested area is like the land use land cover change analysis and mapping, agriculture monitoring, and also disaster risk management related application, etc. So I am pleased to do co-chair in this session along with Ms. Surika. Now, before starting the presentation session, we like to make the same announcement for the session. Actually, we have 6 presentations in this session. The pre-recorded video presentation will be played by the technical team. After that, you are allowed to raise questions after each of the presentation. So please use chat box to raise your questions to the presenting author after their presentations. I will verbally direct the questions to the presenting author. And also, you are also requested to make sure to mute your microphone when you are not speaking. Thank you. Now, we will start the presentation. And first of all, let me introduce the first speaker. The good name is Miss Marta Del Zoppo. She is from University of Naples Patrico II from Italy. She is going to talk about the title of the assessment of typical Sri Lanka school buildings to extreme coastal flooding. Okay, now if you are ready, you can start the presentation.
Hello everyone, I'm Marta Del Zoppo from University of Naples, Federico II, Italy, and today we'll discuss about the assessment of typical school buildings in Sri Lanka subjected to extreme coastal flooding. This research is a part of the Reschool project, Resilience of Schools to Extreme Coastal Flooding Loads, funded by the UK Global Challenges Research Fund 2020. The project involves partner universities from UK, Italy, and 3 universities in Sri Lanka, and also key stakeholders from the Sri Lankan Disaster Management Center, the National Building Research Organization, and the Ministry of Education. The project focuses on the Sri Lankan education system. Indeed, after the 2014 Indonesian tsunami, several building compounds suffered heavy damage with significant destruction and consequences on the coastal community. Many damaged schools showed also evident soil erosion or called scour below the footings that caused partial collapses of the building. So after 2004, most of the damaged school buildings were demolished and rebuilt in the same location. And only a few number of schools were relocated outside the tsunami hazard zone. However, early warning systems in the form of tsunami towers have been installed, and emergency evacuation routes for the students have been also defined in a nearby temple as refuge. The school project looks at assessing the resilience of Sri Lankan education network, looking both at the resilience from the physical and social points of view. The social preparedness to tsunami has been assessed through interviews with students and head teachers. In this preliminary work, I will focus on the physical resilience of school buildings for the proposal of strengthening measures. The first step of the research is the identification of school building typologies typical for Sri Lanka. The 3 districts of Gal, Ampara, and Batikaloa have been taken as study area for the areas for the Institute surveys. A total of 55 school buildings located in the tsunami hazard zone have been surveyed in these past months. 27 buildings are located in Gal, and 28 buildings are located between Ampara and Batikaloa. This is to identify the main diffuse structural typologies and also their current conditions in terms of aging, deterioration, and corrosion. All the schools present almost the same layout with a very open front to access the classrooms and different orientation with respect to the seafront. But from the survey data, the most diffuse building typology in all the districts resulted in this 2-story school building with a total of 8 classrooms. This kind of building is made with reinforced concrete frame and measuring field walls that show it to be very vulnerable during the post-tsunami inundation. After the 2004 tsunami, the Sri Lankan Society of Structural Engineers issued also a set of guidelines for the improved design of school buildings, looking at this particular typical building configuration in order to avoid the partial collapse caused by the scour during the tsunami. In these new design provisions, the structural redundancy was enhanced with the addition of these 2 intermediate columns at the end base of the building, the addition of reinforced concrete plinth beams at the ground level of the entire building, and also the addition of non-breakaway infill walls at the end base in both directions. These infill walls will not fail under the tsunami pressure. They are called non-breakaway infills. So these 2 building typologies have been selected to assess their performance under tsunami inundation, and the effect of tsunami inundation on structures has been simulated through a refined numerical analysis called variable depth pushover for breakaway infill frame, or VDPO-BI analysis, which is able to simulate the distribution of the water pressure on structural components for increasing tsunami inundation depth. And in this figure, we can see the distribution of loads on the elements of the building for different steps of inundation depth. The water pressure induced by the tsunami on structural and non-structural components has been computed following an empirical validated equation, which relates the tsunami drag force to the flow depth and the flow velocity. These 2 parameters are related to each other by the Fred number. And in the VDPO-BI analysis, the fruit number is assumed constant during the analysis, and the performance of the school has been then investigated under different tsunami scenarios characterized by different fruit number and, of course, increasing inundation depths. Of course, a higher fruit number means faster flow, so increasing flow velocity. The performance of the school buildings has been evaluated considering two main directions, namely X and Y, and for a fruit number ranging between 0.6 and 2. For each fruit number, the maximum inundation depth corresponding to an heavy damage of the building has been plotted in this graph. Here, the results obtained for the typical configuration are reported for both directions, showing that the fruit number is affecting significantly the performance of the structure. And so for increasing fruit number, we have a decreasing performance of the building and reduced capacity. Here, the performance of the typical configuration is compared with the performance of the new design proposal from the SSE. The new design proposal, of course, increased the resistance against the scour, but the VDPO-BI analysis showed that this reduced the capacity for lateral loading, so leading to faster achievement of a high level of damage with respect to the original typical configuration for both tsunami directions. For this reason, based on these preliminary results, a proposal for increasing both the capacity tsunami lateral loading and also to avoid the partial collapses during the scour, caused by the scour, has been investigated. This alternative proposal consists in the adoption of breakaway infill walls at the end base. This allows to achieve a better compromise between the two configurations, and so to have a good capacity against scour, and also a quite good capacity for lateral loading, especially in the X direction. The performance assessment of the schools also allow to develop rapid damage scenarios for the Sri Lankan schools for the investigated provinces. Given the expected inundation depths of the building's location, it is possible to assess the number of schools that are at risk to suffer heavy damage. So in this picture, we are looking at the Gulf province for a scenario with a maximum inundation depth of 3 meters. In this case, the heavy damage to the school is expected only if the fruit number exceeds the value of 2. But if we look at the Ampara district, where the inundation depths are greater than 5 meters can be achieved, in this case, several building schools have been identified to be at risk of heavy damage, even for very low levels of fruit numbers. So this analysis allows to assess the resilience of the existing schools and also the new design proposals, and to prioritize strengthening intervention for the schools that are more exposed to tsunami inundation. So to conclude with the Green River School project, we analyzed the prototypical Sri Lankan school buildings and also new design configuration. And the preliminary results pointed out that the fruit number is significantly affecting the performance of buildings and should be properly quantified in tsunami simulation to have a realistic assessment of the risk and resilience of the schools. The design proposal issued by the Sri Lankan Society of Civil Engineering can lead to a reduction of the building capacity under tsunami loading. And for this reason, an alternative design option has been proposed to increase the resilience of the schools. We are now working to develop a probabilistic framework looking at different school typologies and also at the social component through the analysis of the interviews carried out to the students to be integrated in a global resilience assessment procedure for schools in Sri Lanka. Thank you for your kind attention, and please contact me if you have any kind of comments or questions.
Thank you very much, Madam, for the interesting presentation. Now I'd like to invite the question for the Miss Martha. Is there any questions to the speaker? Because I didn't see any questions in the chat box. Is there any questions to the speaker? Yeah. I have the one question, Martha. I'd like to know when will you conduct the survey for the assessment and how you validate the model for the damage mechanism for your study?
Hi, thank you for your question. So about the surveys, the surveys were developed by our members of the team that are in Sri Lanka, and part of them are right now assisting to this conference. So hello. And so they carried out all the surveys in these 3 districts during this pandemic period. So they put their efforts with their students to survey the schools. And after that, we developed the model, and we tried to validate the damage scenarios from the pictures of the 2004 tsunami. So thanks to Professor Dias, we collected some pictures of the typical school buildings that were damaged. And then we tried to compare our analysis results with that damage scenarios, and we found a good match. So in this way, we validated the models.
Thank you for your answer, Martha. Is there any questions?
Dr. Sinha, can I ask a question?
Yes, of course you.
Yeah, Martha, have you done any cost benefit analysis? Basically, the cost difference between the current buildings and the proposed new designs.
Thank you for this question. Actually, not yet, but in the idea of the resilience assessment of the educational system, this can be definitely a good idea to compare also the cost of this new design, and also, of course, comparing also time. Downtown times, the indirect cost of damage of schools in terms of cost benefit, not only considering direct cost, but also indirect cost deriving from the damage of the schools. So yes, this is definitely a good idea to take into account. Thank you.
Yeah, thank you very much. And I have another question. In addition to the education department, who are the other stakeholders in this study? Have you consulted like government agencies like National Building Research Organization and other like relevant organizations?
So at the moment, we didn't contact it yet because we are preparing the first report of this project. So we don't have yet a contact with them with report. But I think of this part will be managed by the Sri Lankan team. So mainly Professor Priyan will engage this kind of relationship with these governmental offices.
Thank you very much.
Okay, I think there's a comment from Professor Priyan.
Yes, we are generally in touch with them. Thank you very much.
Thank you.
Is there any question for Martha? Okay, if there are no more questions, thank you very much, Martha, for the presentation and answer.
Thank you.
Now, let me invite the second speaker, who is Ms. Chandrasekhara. She's from University of Colombo, Sri Lanka. The title of the presentation is the Heavy Metal, Oil and Grease Pollution of Negombo Lagoon in Sri Lanka. Yes, if you are ready, you can start the presentation.
I am Kanchana Chandrasekhara. I am here to share my experiences and outcomes of our study with you. This is the content of our presentation. First of all, I will introduce what is our study and why we compelled to carry out this study. Negombo is a shallow coastal lagoon situated in the Gampaha district of Sri Lanka, which developed during the Holocene period. It has a rich hydraulic regime, which enriched by Athanagaruwa, Hamilton and Dutch Canal. Negombo, one of the most productive estuarine lagoons in Sri Lanka, having a rich mangrove diversity. As the lagoon located just outside the nation's economic capital Colombo, surrounding of the lagoon is one of the highly urbanized areas in the island. The Negombo Lagoon and its coastal environment have had long association with the fishing industry. There are 47 jetties constructed in the canal segment of the estuary. High population density of the area created unbearable pressure on the lagoonal environment. Anthropogenic activities and the development of urban centers on both sides of the Negombo Lagoon and infrastructural development, like highway constructions, are prominent causes for environmental stress in the lagoon. The main international airport that serves Sri Lanka is located close to Negombo Lagoon, making the area an important tourist hub. The development of tourism industry provided ideal frontage for large number of middle-grade hotels, caused unplanned tourism development from the past, increasing the pollution of lagoon water. Waste oil released from motorized fishing vessels and industries established for production of boats discharge their effluents into the Negombo Lagoon, resulting in considerable pollution. Heavy metal contamination in lagoon has received considerable attention throughout the world at present. However, until the recent years, oil has not been widely considered to be a serious threat to inland waters. However, oil pollution has been receiving increasing attention since the middle of 19th century. Hence, the necessity of studying the heavy metals, oil and grease pollution in water and sediment in Negombo estuary is timely important. I will move on to the objective. There are few scientific research available on heavy metal in water and sediments of the lagoon. I could not find any research that has been carried out to study oil and grease pollution in Negombo Lagoon. Therefore, the purpose of this study is to assess the contamination levels of heavy metals, especially the cadmium and lead, oil and grease of water and sediment. I will move on to the methodology. Sampling was carried out in 8 locations. Both water and sediment samples were collected from the same point in each location. The sampling was carried out in March 2014 during the relatively low rainfall period. Absolute locations of the sampling sites were recorded using a GPS receiver. Laboratory analysis has been carried out as per the standard methods of American Public Health Association Manual, 20th edition. A standard Ratna water sampler was used to collect the undisturbed water samples. Sediments of the lagoon were collected using grab sampler. Both water and sediment samples were preserved immediately after sampling by acidifying with concentrated nitric acid. Collected water samples and sediment samples were transported to the laboratory, placed in ice soon after the collection. The tests were carried out to detect heavy metals of the cadmium and lead in water using atomic absorption spectrophotometer at the Laboratory of Water Resource Board, Colombo, Sri Lanka. Sediments were analyzed according to the standard method of microwave digestion detection by atomic absorption spectrophotometry. Oil and grease of the water and sediments were analyzed according to the partition gravimetric method at the National Building Research Organization, Colombo, Sri Lanka. 3 replicate samples were analyzed for both water and sediment samples. The spatial distribution of cadmium, lead, oil and grease were mapped using IDW interpolation technique in GIS. First, I will explain the overall results of the heavy metal, oil and grease. Cadmium levels of water samples were varied between 2.01 to 7.2 microgram per liter. Cadmium concentrations of sediments were between 300 to 1,800 microgram per kilogram. Lead of the lagoon water were between 17.6 to 48.6 microgram per liter, and lead of sediments vary between 12,300 to 18,300 microgram per kilogram. The concentrations of oil and grease of the lagoon water were between 200 to 5,600 microgram per liter, and oil and grease concentrations of sediments vary between 30,000 to 3,720,000 microgram per kilogram. Now I will explain about the spatial distribution of cadmium, lead, oil and grease. We'll see the distribution pattern of cadmium. The concentrations of cadmium of the lagoon water in most locations were close to the threshold level of inland water quality. The water quality standard for cadmium is 5 microgram per liter. Spatially, the highest concentration of cadmium in water were recorded in the eastern and northwestern regions of the lagoon. Western and southwestern segments of the lagoon showed comparatively low cadmium concentration in water. However, the higher cadmium levels in sediments were observed in northwestern and western regions of the lagoon. Then I will explain the distribution pattern of lead. Lead of the lagoon water in almost all the locations were close to the threshold level quality standard. Quality standard of lead is 50 microgram per liter. Especially, high lead concentration of water are observed in northeastern quarter and eastern half of the lagoon. The highest concentration of lead in sediments were observed in northeastern and southeastern regions of the lagoon. However, the eastern segment of the lagoon showed comparatively low concentration of lead in sediments. Now I will talk about the distribution pattern of oil and grease. The high concentration of oil and grease in water were recorded in northern and eastern regions of the lagoon, where the boatyards, filling station and service station are located and industrial effluents are received. Conversely, oil and grease were relatively low in other regions of the lagoon. Especially, the highest concentration of oil and grease in sediments were recorded in southern segment of the lagoon. The concentrations of cadmium, lead, oil and grease in sediments observed in high opposite regions of same parameters have high in water. It may be due to sedimentation. Sedimentation is a long time process compared to water dynamics. Water of the Negombo Lagoon is continuously influenced by tide and freshwater influxes. Thus, the concentration of cadmium, lead, oil and grease of water can be changed frequently than the concentrations of those parameters in sediments. Now, I will move on to the conclusions. Cadmium, lead, oil and grease level of water are high in eastern regions of the lagoon. Cadmium and oil and grease concentrations are high in northern regions of the lagoon. Concentration of cadmium, lead, oil and grease in sediment were observed high in opposite regions where same parameter high in water. Western and southwestern segments of the lagoon showed comparatively low cadmium concentrations in water, and southwestern quarter also showed low concentration of lead in water. These are some references which are used for this study. I should thank following institutions and the person who helped me a lot during the study. Thank you.
This interesting presentation, but unfortunately, I was informed by technical team that presenter was not here. So if you have a question, please ask maybe at the end of the all presentations. So let me invite to the next presentation. I'd like to introduce the speaker. The name is Mr. Ashwin Wickramasuriya. He's from University of Aradhana, Sri Lanka. The title of the presentation is the analysis of the flood vulnerability in Kalutara district using geospatial technology. Please, that is all over to.
Analysis of flood hazard in Kalutara district using geospatial technology. I am Ashwin Wickramasuriya. Ms. Sarangi Walpita is the co-author of this paper. Outline of the presentation: introduction, objective, study area, materials and methods, results, discussion and conclusions. Introduction. Kalutara is one of the main districts affected by floods in Sri Lanka. Each year, especially people who are living closer to Kalu River or Kalu Ganga are facing numerous problems due to floods. At times, these flood events significantly impact on settlements and road networks, which leads to create many kinds of socio-economic issues in the area. Even though few institutes demarcate flood inundation area after a flood event has experienced, less focus has given to identify the possibility of impact on settlements, buildings, and road network can be arose based on factors effect on floods. Rainfall acts as a triggering factor of creating floods. However, flood hazard of an area is depending on the physiographic characteristic of that area. Therefore, in this study, three main physiographic characteristics of the Kalutara district, that is, distance from the Kaluganga and its tributaries, elevation from the mean sea level, and land use distribution of the area are considered to identify the flood hazard in the Kalutara district. To create flood hazard map and classify flood hazardous areas, geoinformatic techniques are applied. Objective. The main objective of this research is to analyze and demarcate the most and least flood hazardous areas in the Kalutara district using geoinformatics techniques. Study area. Kalutara district is in the western province of Sri Lanka. Floods are frequently experienced in Kalutara district and severe floods were recorded in 2003, 2011, 2016 and 2017. The Kalu River in Kalutara district has the basin area about 2,803 square kilometers and has the annual discharge is about 3 million square meters per square kilometer per year. This is because the upper catchment of the Kalu River is situated in the highest rainfall receiving region of the country. Materials and methods. The steps in the methodology are given in the following flowchart. There are two main steps in the methodology. Number one, creation of the database. Number two is preparation of the flood hazard map for the Kalutara district. The database has created using digital thematic layers. The flood hazard map preparation has involved a few steps. First, set the criteria or identify the factors effect on floods. Then assign weightages and ranks for those factors. Then standardize those factors. Finally, using weighted overlay method, created the flood hazard map for the Kalutara district. Thereafter, that map has validated using past flood events in the Kalutara district. Materials and methods can be summarized as follows. Preparation of the base map and the thematic layers, using maps obtained from the Survey Department of Sri Lanka, assign weightages for factors, using pairwise comparison method, assign ranks for different conditions within factors, using scale of relative importance, preparation of the weighted thematic layers, using digital thematic layers, and preparation of the flood hazard map by weighted overlay method. Results. Based on previous studies and after consult the experts, it was identified that the distance from the drainage network, elevation, and land use types are the main physiographic conditions influenced to create floods. These three factors do not contribute to create floods in the similar manner. Therefore, based on the strength of their contribution, weightages are assigned for each factor based on pairwise comparison method as shown in two tables. So according to this analysis, the weightage assigned for distance from the drainage network or the water buffer is 0.544, while the land use has assigned 0.110 and the weightage assigned for the elevation is 0.346. To check the validity of weightages assigned for factors, the consistency ratio has calculated using the following equation, where CR is the consistency ratio, CI is the consistency index which is calculated using this equation, lambda maximum is the principal eigenvalue, n is the number of criteria, Ri is the random consistency index. The consistency ratio obtained from this calculation is 0.059, which is much below the threshold values, that is 0.1. Therefore, the weightages are assigned for each factor has high level of consistency. Different conditions within factors influence to create floods in different manner. Therefore, ranks are assigned for different conditions within factors based on scale of relative importance as shown in below. The water buffer or the distance away from the drainage network has classified into 5 classes based on the buffer or the distance away from the drainage network, and these ranks are assigned. Elevation, based on the elevation, has divided into 4 classes and appropriate ranks are assigned. Similarly, land use has divided into 5 classes based on land use type and their ranks are given here. Discussion. Weighted thematic layers are produced considering ranks assigned for each thematic layer. This is the weighted water buffer thematic layer. This is the weighted elevation thematic layer, and this is the weighted land use thematic layer. Flood hazard map has introduced by weighted overlay technique available in ArcGIS software using created weighted digital thematic layers. When these weighted digital thematic layers are overlaid, GIS software will automatically generate a digital number for each pixel. So in here, that pixel value is referred as flood hazard index, which is created using weightages and ranks assigned for each factor. Based on the flood hazard index, flood hazard map can be classified into different flood hazardous areas. Based on digital pixel values in the flood hazard map, flood hazardous areas in the Kalutara district has divided into 5 zones: very low, low, moderate, high, and very high. Created flood hazard map has validated by overlay with the flood inundation map introduced for the Kalutara district by the Disaster Management Centre of Sri Lanka in collaboration with Department of Irrigation in 2003. After this analysis, it was noted that very high and high flood hazardous zones in the flood hazard map are associated with flood inundation area demarcated in 2003 flood inundation map. Conclusions. Each year, there are floods occur in and around Kaluganga. Therefore, it is very important to introduce flood hazard map for this area. To create this map, most updated and most important causative parameters contribute to create floods, that is, distance from the drainage network, elevation, and land use are considered. Weightages are assigned for 3 factors based on pairwise comparison method. Ranks for different conditions within factors are assigned based on scale of relative importance. Flood hazard map for the Kalutara district has introduced using weighted overlay technique with the help of ArcGIS software. Created flood hazard map has validated using information of past flood event in the area. This analysis shows that the created map can be accepted. According to flood hazard map, flood hazardous areas can be classified into very high, high, moderate, low, very low, and are 5.09%, 9.22%, 16.65%, 16.49%, and 52.55% of the total area of Kalutara district respectively. The created flood hazard map can be utilized to minimize damage created by future flood events in Kalutara district. Some of the references are given below. Thank you.
Thank you for the presentation, Mr. Ashwin. Now I like to open the questions from the floor. Are there any questions to the presenter? And I have seen one question. How about the flood duration? Can you please answer, presenter?
Hello, can you hear me? Hello?
Yes.
Can you hear me?
Yes.
Yes?
Yes, we can hear you.
Yeah, can you repeat the question,
The
please?
question is how about the flood duration? Can you hear me? The question is how about the flood duration?
Fluctuation?
Yes.
Duration.
Flood duration. Flood duration. How about the flood duration?
Flood duration. So,
Yes.
according to this map, this is a map created using the thematic layers. We didn't consider about how many days that is the inundated area, inundated time, but we consider the physical parameters, not the exact situation of the flooding. So we consider the distance from the river or the tributaries and elevation and the land uses. Hello?
Yes.
So but we didn't consider about how many days that flooding has happened, but we measured the maximum water level, maximum water distance from the river. Right? So that is the maximum date that the flood inundated date.
Yes, the question is from the Professor Wiyasinki.
Hello?
Professor Wiyasinki, are you there? Is he answering your question?
Hello? It's not clear to me. Hello?
Yes, I can hear you, but okay, thank you for the answer. And I have the one question.
Yes.
As you have used the 3 factors for MCDA analysis, like the distance from the river, elevation, and land use.
Yes.
I'm so interested in your topic because we are also doing the flood analysis for urban areas. So it's nice to know the flood vulnerability map using that MCD analysis is also acceptable. And I like to know how you think if we include the curve number for runoff factor for analysis.
Rainfall factor, right? Is it?
Yeah, runoff factor.
So this is when I consulted the experts, so they have the idea that if the rainfall has considered, we are double counting because the rainfall is indirectly it is contribute to the discharge. So discharge, so that from the distance away from the river is counted using the rainfall, because if you add the rainfall also, So if you consider entire country, it is okay. It can be considered as one of the factors. But this is the district, Kalutar district. So if you count the rainfall data, also we are double counting for the discharge or the inundated areas, so distance away from the river. So that is why we exclude the rainfall as a parameter.
So it means no need to consider the CAPNAM grid map for input layers.
Rainfall, if you include the rainfall thematic layer also for the weightage analysis, so it will be double counting, because the rainfall, so it can be act as a triggering factor. So if it heavily rain, so what will happen? The distance away from the river is moving away from the river, right? So it's maybe early. So if slightly rain, so 1 kilometer. Maybe if heavily rain, can we go up to 1.5 kilometers? So if you add thematic layer, the rainfall thematic layer, what will happen? So we are double counting, because that rain, that water is also encountered for the discharge. So flood, maybe that is also counted. That is why we exclude the thematic layer rainfall.
Okay, thank you for your answer. And
Dr. Sinma, can I ask a question from the present?
yes, please.
Ashwin, what are the salient features of the land use in your study area? Are they mostly like settlements?
So the paddy fields, then the beaches are there, paddy field. So those are in the low elevated areas. But some areas, there are some rock outcrops and some high elevated areas. So the coconut, then the paddy field areas and the beach can be considered as given as high weightages after consulting the irrigation department engineers, irrigation engineers, and also some of the expert in the disaster management center. Because sometimes if you have the rock outcrop, so definitely, or the high elevated areas are consist of rock outcrops. So that areas, in likely to have experience floods. So they are giving the low ranks or the low weightages.
Thank you for your answer.
Thank you.
Are there any questions to the presenter? Okay. Okay, I didn't see any questions in the chat box. So thank you very much, Mr. Ashwin, for your presentation and your answer.
Thank you very much.
Okay, so far now we finished 3 presentations. So let me invite the next presentation. The presenter will be the Mr. Malik. He will present about an assessment on the capacity needs to implement in MOC system in the developing countries in Asia with reference to the energy efficiency and climate change focus group survey in Sri Lanka and Bangladesh and the BAC project. So you can start the presentation, please.
A very good day for all of you. This study is about an assessment on the capacity needs to implement a massive open online courses in the developing countries in Asia with reference to energy efficiency and climate change. A focus group survey in Sri Lanka and Bangladesh under the BEC project. It's presented by Malit Seniviratne, a researcher attached to the Global Disaster Resilience Center, School of Applied Sciences in University of Huddersfield, UK. The co-authors of the research are Professor Dilanthi Amratunga, Professor Richard Hai from University of Huddersfield, UK, Mr. Chamili Priyankara, Professor Nandasiri Veerasinghe, Professor Champa Navaratna from University of Ruhuna, Sri Lanka, and Professor Arturas Kaklauskas from Gediminas Technical University, Lithuania. Improving climate literacy via education on climate change has been considered as a key element in Sendai framework across its 4 priorities. Also, quality education is emphasized across all the related sustainable development goals. The The practitioners are increasingly emphasizing the importance of learning and capacity building as they research for solutions to build sustainable cities while addressing the challenges, including climate change, disaster risk management, biodiversity loss, and sustainable production and consumption. Education is critical for helping people to adapt to the consequences of climate change, especially in developing countries where agriculture provides the main economic gain. Building disaster preparedness requires significant long-term investments in education. The World Bank notes that incorporating climate change education in higher education curricula is an important step. Since the knowledge of climate change extends across different geographic regions and environments, also as the COVID-19 pandemic has enabled a novel dimension of socializing, distance learning and online teaching methods are considered as effective modes for delivering climate change education. Having recognized the mentioned needs, BEG project, supported by the European Commission, aims to support partner institutions for developing new harmonized massive open online course modules to the higher education curricula of 14 higher education institutions in the field of energy efficiency and climate change. The 14 partners are consisted of 4 European institutions, 5 Russian institutions, and 5 Asian institutions from Sri Lanka and Bangladesh. The BEG project facilitates the partner institutions with cross-institutional knowledge and resource sharing to mobilize the resources as identified in the initial capacity needs assessment while supporting to adapt ICT platforms for delivering climate change education. The massive open online courses in climate change education is expected to facilitate a comprehensive online platform, especially to achieve in-depth comprehension about the essential principles of Earth's climate system and scientific information about climate change, and also to enable wider dissemination of the information about climate and climate change and develop capacity to make informed decisions that may affect the climate. Among these requirements, the higher education can be considered as the effective level to integrate climate change education because the existing curricula can be upgraded with knowledge from climate and sustainable development perspectives, and as the modules can be specified and adaptive on different course levels. And also, the higher education allows the industry collaboration and the involvement of interested groups across the world. As the partner countries of this study, the National Climate Change Strategy and Action Plan of Bangladesh can be identified to include 6 pillars, including comprehensive disaster management, research and knowledge management, capacity building, and institutional strengthening. Major goals under the National Climate Change Policy of Sri Lanka are to raise the adaptive capacities, resilience, and capture opportunities for reducing the vulnerability of communities and ecosystems for climate change. As the partner countries, Russia's main climate change policies consist adaptation to climate change, prevention of climate-related natural and technological hazards, and improve education about climate change. The European countries are highly adapting online education for disseminating their climate change policies and for improving literacy of their communities about climate change. Therefore, common agendas can be found in all the partner country climate change policies. However, the challenges and capacities within the country varies in large extents. Therefore, to implement massive open online courses in the identified partner higher education institutions, the project carried out a capacity needs assessment survey to analyze the context of subject needs and cross-institutional resource sharing capacities. The aim of this study is to explore the capacity needs in the partner country higher education institutions to integrate climate change education into their higher education sector via open and online platforms. The three-dimensional framework for assessing capacity needs by UNESCO was used to understand the capacities, policy domains, and functions that shape the general policy formulation under micro-educational level. A focus group survey and stakeholder workshops were carried out to assess the factors influencing teaching and learning mechanisms on climate change education via open online platforms among the partner country higher education institutions. Key findings from the capacity needs assessment survey can be identified in capacity building for infrastructure and policy development, policy implementation, and functional development at macro, micro, and meso levels. Some of these include climate change education needs on research and new knowledge development, and integrated national formal and non-formal education, budget allocation for infrastructure and human resource development, and effective mechanisms of necessary national policy provisions and implementation. Also, insufficient allocation of funds for educational policy development, gaps in evaluation, revision, and reviewing procedure of education policies, lack of lateral coordination between regulatory bodies, gaps in policies on e-based learning, vocational education, insufficient standards for higher education policies can be identified. The accreditation of massive open online courses, credit transferring system, and modular sharing among partner country higher educations, lack of partnership agreements among partner institutions are identified as emerging issues for implementing and maintaining massive open online course modules. Accordingly, the findings were classified into 7 key areas of capacity needs for implementing massive open online courses in the partner educational system. To carefully address these capacity needs, the project developed a comprehensive framework which assists the recipient institution with extended support for preparation, development, quality assurance, dissemination and exploitation, and management of massive open online course implementation. The big capacity building initiatives address the micro-educational level where the capacity building is intended to take place through demand-driven processes of learner-centered intelligent tutoring system that empower and place the learner in a central and active position. It allows learners to build and enhance knowledge and skills and adapt to change. Based on the scope and capacities of the project, it facilitates the actions extend across introducing new multidisciplinary adaptive recognized and certified MOOC modules, transferring European practices in education for learning and teaching tools, including pedagogical approaches, learning outcomes, and ICT practices, developing the simulated Big Data Inter-University Network Effective Educational Center, known as the BEC Center, to encourage the use of ICT in MOOC implementation. The major two developments that are currently underway with the partner country higher education institutions are the new 24 adaptive MOOC modules related to energy efficiency and climate change, and the simulated Big Data Inter-University Network Effective Educational Center is the centralized body for MOOC module dissemination, which consists of ICT infrastructure to host the modules and learning environments. Accordingly, the BEC project capacity building framework provides an orderly sequence of the preparation, development, quality assurance, dissemination, and management support for the implementation of BEC MOOC modules. The advantages and limitations identified by the curricular development and capacity building is further studied to harness the inter and intra-institutional potentials for wider improvements and minimize the effects of limitations over alternative solutions. The BEC project capacity building framework establishes a wider cross-institutional partnership development facilitated by knowledge, resource sharing, and coordination to elevate the capacities of partner institutions for MOOC implementation. The framework ensures the quality and consistency in the MOOC implementation by providing the necessary guidelines for the structure of the MOOC, use of technology, and pedagogical methods depending on the aims of the modules. One of the major limitations of the BEC project capacity building framework is the identified partner country higher education institutions' capacity needs, which require wider collaboration and policy inclusion, which is not currently included in the project scope. Insufficient national institutional engagement, absence of legislative framework for international collaboration, lack of policy-level training for research and innovation are major barriers for mainstreaming the climate change education in the partner country education system. Therefore, the project continues to include the policymakers in the decision-making and coordination meetings to collaborate for policy adaptation for MOOC development in the higher education sector. The BEC framework contains general philosophical, pedagogical, and practical understanding and capabilities of partner institutions which form a basis for development of the massive open online course modules and can be customized and adapted into other similar projects to achieve long-term sustainable capacity development. The authors would like to acknowledge the support from the European Union Erasmus Plus program for capacity building in the field of higher education for financing the project activities. The Earth has music for those who will listen. Thank you very much for your attention.
Thank you very much, Mr. for your interesting presentation. Now, I'd like to invite the questions for the presenter. There's a question in chat box. Interesting presentations. My question is about what are the barriers that you have identified within Asian countries MOOC, and what are the areas need to be improved within Asian context of MOOC?
Yeah, thank you very much. Yes, thank you for the question. So basically, now I would like to answer that question with the methodology that we use. Now, as I explained, we use the capacity assessment survey, which was proposed by the UNESCO for this for identifying these capacity needs. So basically, we studied 3 areas, starting from the functions, especially at the micro level. I mean to say that the massive open course module development. So the functions that are needed when it comes to the content, and then when it comes to knowledge, where we can get the updated knowledge, and then the barriers with these geographic distances, and then how to especially with reviewing and accreditation of massive open course online modules when it comes to the Sri Lankan and Bangladesh content. So these micro level capacity needs are as in functions we studied in detail, and then we studied about the capacities that are needed to implement these things, integrate these things into the Sri Lankan and Bangladesh higher education sector. And then on top of that, we have the policy domains which will support the implementation of this process. So under these 3 areas, the functional needs and capacities and the policy domains, we identified like in detail needs that were specified from the partner institutions in terms of their requests. So how we are facilitating these capacity needs are mainly with the support of the European and Russian partner institutions that are within the project. So the European institutions, especially, they are highly equipped with online teaching materials and the expert knowledge, and especially with the research partnerships. So we are harnessing their potentials with the European universities and giving the inputs for the Asian recipient institutions so that they can develop further research and development and collaborations for implementing the massive open online course modules. So currently we are at the process of developing this. Actually, we have 24 massive open online course modules being developed within the partner institutions. That includes PhDs, masters, and bachelor levels. So under all these 3 higher education levels, we are developing modules currently, and then we are going to develop a virtual inter-university which will host all these modules and will be like disseminated openly for all the communities who are interested in. Yes.
Thank you, Mr. Is there any questions more to the presenter? Please use chat box if you have questions. Yeah, can I have a question, Mr.?
Yes, sure.
After you have done the assessment of the capacity needs by ASEAN in partner institution, right? After implementing the online course module, it will be accessible through website by everyone or by only by the partner institutions?
No, it can be accessed by everyone, but there will be certain standards where who will be offering the course. So it will be like offered based on the host institution. So what interested students, they have to register at the partner institution in terms of their module or the course program, and then they can carry out the studies online. So the big center will be the inter-university, which will be disseminating all the knowledge with online education, and it will allow the partnership, allow the discussions with supervisors or training modules. But the module will be offered by the host institution. It means the student has to register at the host institution as a student and then carry out the module. So like it is just to ensure the accreditation and then the quality and standards of the knowledge that's being shared.
Okay, thank you. And please let me see any more questions. Surika, do you have any questions or?
No, thank you very much.
Thank you very much.
Okay, thank you.
Thank you.
Thank you. And now I'd like to move for the next presentation. The speaker is the Professor Via Singhi from University of Ruhuna from Sri Lanka. The presentation title is Qualitative and Quantitative Assessment of Plastic Debris in the Coastal Ecosystem of Matara District, Sri Lanka. Yes, it is over to now.
Good afternoon, ladies and gentlemen. I'm Tanya Veerasinghe. Today, I'm going to discuss about our study on qualitative and quantitative assessment of plastic debris in the coastal ecosystem of Matara District, Sri Lanka. Plastic, if we talk about plastic, this has become an issue on a global scale. So Sri Lanka is also facing a plastic crisis at present. Plastic is quite popular in Sri Lanka due to its low cost, durability, and availability. However, in Sri Lankan context, in general, waste is poorly managed. This includes plastic waste as well. In a recent study, it was found out that 75% of the waste collected in the Western province was thrown into open dumps. So the Western province is the largest waste generator out of the all provinces in Sri Lanka. To further this problem, there's a lack of regulation regarding dump sites. Now, because of this illegal dumping, we have problems occurring in ecologically sensitive areas such as wetlands and along the riverbanks, as well as within declared conservation zones. It's hard to put a start and an end to the plastic waste problem. Improper plastic littering causes environmental pollution, not just land-based environmental pollution, but the pollution of the marine environment. This has been a topic of discussion lately. So if we consider about the coastal environment, according to a study done by Jambek in 2015, Sri Lanka was identified as the 5th plastic polluters of oceans. So number 5 is a big number for a small island nation to have. Further, a study by Jung reported the highest density of plastic accumulation in the southern coastal line through their island-wide survey of the coastal belt of Sri Lanka. Therefore, we focus the current study in Matara district, which is part of the southern coastal belt. So the objectives of the study were threefold: as to quantify and assess the types of plastic accumulated in the coastal environments, to assess the level of community involvement in managing coastal plastic, to discover possible solutions identified by stakeholders involved in the plastic journey. This is the methodology. In order to achieve the objectives, the following methodologies were employed. So for the coastal survey, first, few sites were selected, and within the site, a demarcated area of a 10 by 10 meter quadrant was selected for the study period. And within that larger quadrant, 3 small quadrants, which were 1 square meter, were marked along the diagonal. And within those small quadrants, all the plastic and polythene debris were collected. Once these plastic debris were collected, they were identified, counted, measured, and then the data was recorded. After this process, all the debris, including the organic matter, were removed from the sampling site. The monitored sites were 5. As you can see in the diagram, first one was Waligama Beach, next Waligama Lagoon, or else known as the Polwatu Modara Estuary, then the Totamina River mouth, Valamadama Beach, and Dondra Lagoon. So the social survey was conducted to understand the impact of coastal plastic in the day-to-day lives of the locals living in the area. So semi-structured interviews were conducted to identify the perception of the participants about plastic and the plastic waste, to understand how coastal plastic has influenced the daily lives of the participants and what actions they have taken to mitigate the problem of coastal plastic and the costs associated with it and the effectiveness of such actions. So these are the participants that took place in the social survey. As you can see, there are different types of participants that included in the sample. Finally, a stakeholder workshop, actually 2 stakeholder workshops were held, one in Matara and another in Colombo, to get the inputs of stakeholders who are involved in the plastic journey. So the workshop aimed to gather information and ideas on managing coastal plastic. The workshops targeted approximately 40 diverse participants. So these stakeholders gave their inputs about managing coastal plastics during these workshops. Next, I'm moving on to the findings section of the study. So we are going to look at the coastal survey first. The plastic waste collected were categorized into 4 categories: in consumer products, packaging material, fishery-related material, and other material. And this table shows the average number of plastic items which were found per 1 square meter of the study sites.
Now, if we look at these numbers, we can see that other particles, that means breakdown of larger plastic products and clinical waste, are higher in Waligama Beach, Totamuna River mouth, and Wallamadama Lagoon. But when it comes to Polwathu Modara estuary, end consumer products took a higher number. So we found kitchen appliances, yogurt spoons, yogurt cups, even the sanitary items among plastic waste in Polwathu Modara estuary. And when it comes to Wallamadama Beach, fishery-related materials were high. So the Dondra Harbour was near the Wallamadama Beach. So the waste dumped by the fishermen floats to the Wallamadama Beach. So we could see a lot of rigiform associated with the fishing industry accumulated along the shorelines of Wallamadama Beach. And this chart shows the litter accumulation pattern during the 4-week study period. Now, as you can see, the accumulation levels have dropped towards the end of the period. This could be associated with a drop of wave action and the less rainfall towards the end of the study period. Also, tourist season was approaching towards the end of the study period. Now, when the tourist season approaches, usually locals conduct beach cleanups to attract tourists to these coastal areas. So these might be the reasons why there's a drop in the waste accumulated towards the end of the study period. Next, we will look at the findings of the social survey. So we will look at the findings column by column. So first, let's look at the impact of plastic. So the impact of plastic was mainly toward the tourism sector and the fishing industry. So plastic waste interferes with tourism activities as it destroys the aesthetics of the beaches and it disturbs the fishing activities of the fishermen. Also, it affects the mangrove associates and other flora in the area when it came to Wallamadama Lagoon. Now, if we discuss the actions taken by the communities, the actions were mainly twofold. One, doing beach cleanups. The next one was to burn plastics, even though burning plastic was banned by the government some time back. At one instance, we identified a fence built to keep the plastic waste entering the premises. Next, the reasons for plastic accumulation. So the major reason for plastic accumulation is the water waste. So plastic waste gets carried via waterways to the coastal environments. So this was the case when it comes to Waligama Beach. This was the case in the Polwathu Modara site where plastic was carried by the Polwatha River. And it was the case in Thotamanu Estuary where litter was carried by the Nilwala River. And in Wallamadama Lagoon was also litter carried by water waste. And when it comes to Wallamadama Beach, it was the ocean that carried flowed plastic to the shoreline. The next major reason for plastic accumulation was littering done by tourists. Finally, we are going to look at the findings from the stakeholder workshops conducted. So these are few of the inputs given by stakeholders to manage the plastic problem. So one is to introduce an emergency phone number to complain about improper plastic dumping and disposal. Next, it was suggested to have a concept village where the village goes plastic free. Another suggestion was to make the Grama Niladhari or the village leader a change agent in managing village level plastic waste. This also means establishing a chain linking stakeholders involved in the plastic journey. Then providing small scale plastic chopping machines to households, installing a net to prevent waste transferring from rivers to the oceans, and conducting awareness programs at different levels were suggested by stakeholders as solutions to manage the plastic waste problem. Now we are at the conclusion section of this presentation. So I'm going to sum up all the findings through this slide. So the key source of marine plastic pollution are linked to upstream dumping into inland waterways. And the next one is inattentive litter behavior of the beach users. The study reported that clinical waste and other plastic particles were the most abundant type of plastic debris accumulated in the southern coastal belt. Plastic waste have been interfering with the livelihoods and daily actions of the communities, and the biggest impact was to the fishing industry and the tourism industry. Local communities have taken actions to manage plastic waste by burning plastic waste and by conducting beach cleanups. However, these solutions were temporary solutions. So we have identified that lack of proper knowledge and environmental responsibility and improper waste management systems are the main reason for coastal plastic problem in Mathura district. So these are the key references of this presentation. Thank you for listening to the presentation. I'll be happy to answer the questions the participants and the panel of discussants have now.
Thank you for the presentation, and it's so interesting. And actually, we have the limited time, and we may have very quick question to the presenter. How you monitor the pollution of the plastic debris in waterway? I mean, what is the survey method for the study?
Actually, plastic was accumulated in the shorelines that was measured, not what gets carried via the waterways. So whatever plastic that gets accumulated on the shorelines were counted and measured.
Okay, thank you. Thank you very much. Now, I'd like to invite for the final presentation. The presenter is Mr. Mahendra Jagat from Disaster Management Center from Sri Lanka. The title is Introducing Preparedness Parameters for Sustainable Settlement in Sri Lanka, Application of Pinheiro Principles to Sri Lanka Settlements. Yes, please start the presentation.
Good evening. I will be talking about the Sri Lankan resettlement process and what we can take from the Pinheiro principles to make the resettlement process more sustainable and successful in Sri Lanka. I'll be taking Aranayaka landslide occurred in 2016 as example. There, the Aranayaka division, which is in Kegor, in Central Province were affected. Family-wise, 756 families were affected, and 2,401 individuals were affected, out of which 31 deaths and 96 missing personnel, with 72 fully damaged houses and 285 partially damaged houses. And still 586 families are at high risk. In these statistics, however, 14 houses have been washed away completely. They were not included into our process, and 74 families voluntarily rejected the resettlement process, and hence they are also not accounted for. So the basic process in Sri Lanka is that when a disaster occurs, the displaced individuals will be transferred initially to a safety camp, which is maintained by the DMC and the NDRC, and then for temporary shelters before resettlements. Additionally to that, individual occupying in high-risk zone will be resettled in safer location. This will be handled by the district secretariat with the guidance of MBRO, who does high-risk zone analysis. With the consultation of Grama Niladhari, who is the grassroots level administrative officer, the individuals can submit all documents for a claim to Minister of Disaster Management or the National Disaster Relief Services and Center. After the damage assessment, so this is done by the government staff who are skilled to do so, and they determine the restitution or the compensation amount. Then the amount will be approved and released by the Minister of Disaster. So in this process, I mean, this shows a rough flow diagram on like how you get restitution. So if you are affected by a disaster, which safe side goes as yes, then you do get compensation from the National Insurance Trust Fund for fully damaged houses and partially damaged houses. The compensation amounts differ, but this insurance was discontinued as of April 2020. But if the site or if the household has not faced disaster yet, but could be directly affected by a landslide or are living in an identified high-risk zone, they will be entered into the resettlement process. And the government provide with 3 options of financing. So first is giving 1.5 million to purchase a land with a house, or offering 1.2 million to construct a house when the land is given by the government, or to purchase a land of 0.4 million and the house will be constructed by the government. Would like to mention none of these options is not, I mean, it's only 3 options. So all the individuals who are affected does not choose in their own free will because they're very limited, and it could lead to unsuccessful resettlement. So these are the principles that we are taken into consideration in Sri Lanka. So housing and property restitution, non-discrimination, adequate housing, national procedures, institutions, and mechanisms, accessibility of restitution claims procedures, and compensation. Okay, so these are the current issues that we face now in resettlement projects, and it causes non-sustainability. So before I begin any of that, I would just like to say that the processing time of the claims are very long, and it causes most of the victims to stay in safety camps or temporary shelters. So many of the victims do not like to go in this claim process because of it. Then you have sociological issues with change in neighborhoods, schools, displaced pets, environment and surroundings, climates, etc. And then you have cultural issues like not having opportunities or individuals to continue cultural activities like community almsgiving, cleaning projects, and we have Vesak decorations, community gardening, like that. And then, of course, we have religious issues with absence of a religious place or to continue the activities and worships. And lastly, economical issues, change in livelihoods or having no access or restricted access to workplaces. Example, in paddy fields. So most of the farmers in Sri Lanka lives really close to the agricultural land. It makes handling and attending to farming very convenient, and resettlement causes a huge loss in that, and hence you can observe reduced economical incomes in resettled families. So what are Pain Hero principles? So they are accumulation of more than a decade of international and local activities, which leads to right to housing and property restitution as a core remedy to displacement. So it has 23 principles in all, and the link here will give you the downloadable document for the principles. So out of 23, I will be only talking about around 6 that we can adopt to the Sri Lankan system. So principle 4, the right to equality between men and women. Equality should be given to both man-headed and women-headed households for legal security of tenure, property ownership, equal access to inheritance, control of and access to housing, land, and properties. Principle 6, the right to privacy and respect for the home. State providing protection against unlawful interference at the resettlement sites, and then providing housing with sufficient privacy. I think we do cover a good amount of respect and privacy when it comes to resettlements. However, always you can improve on. Then to principle 9, the right to freedom of movement, the right to choose his or her residence, which the government or the authorities can be forced to remain. The victim cannot be forced to remain within or leave a certain territory, area, or region. Then principle 11, compatibility with international human rights, refugee and humanitarian law, and related standards. So these standards could be applied for housing, land and property restitution, procedures, institution, mechanisms, and legal frameworks. And then international human rights, refugee and humanitarian law, and related standards should be incorporated and maintained to achieve sustainable resettlements. And principle 16 and 17, the rights of tenants and other non-owners and secondary occupants. I think these principles or these parts, areas have not yet considered in the Sri Lankan system, but it's very important to plan
For
and
interruption and
enable mechanisms for these as well.
the time was
And
urgent.
then
We
principle
have
14,
stopped
adequate
presentation.
consultation and participation.
I'm sorry for interruption. That session is near about to over, and please let me hand over to the chair. I'm sorry for interruption. Now, I'd like to hand over the floor to the chair to discuss about the summary of the session, as another session will start at 3:30. Sorry. Thank you.
Thank you, Dr. Zinma, for facilitating the presentation. And I take this opportunity to thank all the presenters for all your interesting and informative presentations, and most importantly, for your research work, as your work will contribute to building resilience of vulnerable communities. I think this session covered preparedness from many different angles, ranging from biophysical, socio-economic, and environmental aspects, such as waste, pollution, and also assessing the vulnerability plays a huge role in preparedness, not only in preparedness, but also in long-term risk reduction. These are two sides of the same coin. So these assessments serve as a foundation for evidence-based preparedness and targeting to optimize the impact. With that note, once again, thank you very much for the interactive discussion, and we look forward to meet you all in the next symposium. Thank you very much.
Thank you.
Thank you, Surika. And now I'd like to announce the session is over. Thank you very much, all.